measurement that has been carried out is what you got at a particular point. But then this silt loading rate that has been measured before and after is that exactly reflects to the amount of silt on top of the road surface. So for which purposes these mechanical sweeping machines are employed. So from that case you can see the academic campus, the IIT ISM campus is having very less silt loading rate within our campus, because our entire campus is not having unpaved shoulders. You see that it is completely end-to-end paved. So the amount of silt loading is very less. But the public roads are typically having the high values around 70 grams of silt per square meter of area. So you can see, what we did is that once the mechanical sweeping machines been employed in a road, then because you cannot expect it to be last forever, right? Today morning the vehicle is run, then after 3.5 days, then the values come back, the silt loading rate comes back to the initial value, what it was before running of the vehicles, mechanical sweeping vehicles. So that is what I showed, like regrowth factors. So that means you get idea about from design point of view. If you want it to be to a certain designed limit, then you get idea about how many times to run the mechanical sweeping machine at what intervals. So instead of just running it once a day or once in a 2 day, then you get to do it according to the amount of silt on the particular road type. So you can choose a different frequency of interval according to the amount of silt load on the different types of road. So now I will move on to, this is the concentration of the elements. So we have divided the results according to the types of road. So we have grouped the results in the heavily trafficked and paved and unpaved roads. Then the second one is the academic campus, IIT campus roads. The last one is the background soil, which is not influenced by the traffic emissions. So the zinc, barium, chromium, lead, copper, these are all the top 5 most elements that are, you can see clearly the background soil had lowest amounts, and academic campus had a higher amount, but not like the common public roads, heavily trafficked roads. So these elements, all of them could be tracked to that of the source from the transportation. So for example, zinc is abundantly found in the tires. So the erosion of the tires and tire wears that are part of the soil, that indicates it is from the vehicles. Similarly, the chromium, the engine wear, you can see the lead. So everything is related to the transportation sector. So through the studies, we are able to make a conclusion that only a part of the road is being swept by the mechanical machines. So you will have to cover the entire width of the road, or if you, because that is going to, you will have to spend a lot of money. The purchase of more vehicles, and as well as the energy consumption by the vehicles, the salary to the staff. Then the collected silt has also been safely deposited, because we have the solid waste management people, whereas in abroad or European countries, you are not permitted to put this collected silt in an open area. This also because they are rich in elements. It can be reused maybe in construction or maybe in another sectors, but it has to be treated. It cannot be just openly dumped. So this is, we come up with the influence of the individual variables upon this dust management. And I have a small second part of the study, in which I am talking about in overall about the traffic management on the air quality levels. So already I spoke about the exhaust emission and non-exhaust emission. If you talk about, okay, silt is contributing. If there are no silt, there will be no resuspended dust. It is agreed. You will have to get rid of the silt. So why silt is coming into the road? If there are edges of the road is having unpaved shoulder, then definitely there will be exchange of the silt from the edges of the road to the center of the road. If you convert the roads from end-to-end pavement, then there is no scope of any silt is freshly coming into the road surface. So okay, that is one part of the problem. Second part of the problem, with increase in number of more vehicles, because I told you that the roads are designed to cater the service for the vehicles. But if the road width remains same, but the vehicle number keep on increases exponentially, then the time comes when it gets the travel duration start to increase because of the traffic jam, or technically we call it as congestion, right? So this is called the traffic system management. If you manage the traffic system, then only you will be able to manage the emissions caused by the tailpipe emissions. So one way is you can add a retrofit to the tailpipe where you can reduce the some amount of emission. So this is the research from end-to-end pavement, which I am talking about, from unpaved shoulders. So you can see when the roads are having unpaved shoulders and the silt content, then the concentrations you can see in 400s, 300s or close to the 500s. And very recently, the same roads have been converted by end-to-end pavement that you see in the last picture. So when it has been converted to the end-to-end pavement, then the concentrations are 3 to 4 times or lesser than what it used to be for unpaved shoulders. So that clearly shows that it is a one-time investment. So you get rid of these unpaved shoulders, at least within the city premises. It is possible to manage the resuspended dust. This is one way to get rid of it. So the other part is all about truck rerouting, the fourth point, where the separate lanes are created for the heavy duty vehicles. You can see in Delhi, Pune and other places. One way to manage the congestion is that the slow moving public transport vehicles, if you give a separate lane to them, the problem why we are experiencing congestion is that there is no lane discipline, right? So if a dedicated lane is given for two-wheelers, cars and buses, and everyone uses the same lane, then the congestion can be bit managed. But what happens is that if wherever there is a space, two-wheelers and auto, people will come and occupy it because their vehicle size is small. The larger vehicle have to stand in queue. They will bypass and they will occupy all the possible openings between the big vehicles. So that's how it starts to create jam in addition to the services or restriction in the width of the road. So the one possibility is that in abroad they used to study the rerouting or creating a separate lane. The another method by which predominantly European countries they start to work on is increasing the vegetation barrier on both the sides of the road. So vegetation barrier can act like arresting the dust, but then the effectiveness of the vegetation barrier depends upon the initial concentration. In a place where there is no silt, then it may be effective in cleaning the gaseous pollutants or whatever comes from the tailpipe emission. But in a place where you have a silt, then even if you grow a vegetation barrier on both the sides, then this problem cannot be solved. So that may be more beneficial in European countries where there is no silt, but in typical Indian conditions, no lane discipline exists, then we do not have end-to-end pavement on roads. So these are the major hindrance for us to clean the air. So we are spending more money, there is a scheme, but still we need to work on finding its efficiency, and then we need to look for modification to it. So I will conclude my talk over here. Question session will be last, right? All of us. Okay, thank you.
থ্যাংক ইউ স্যার। স্যার আমাদের কয়েকটা খুব ইম্পর্টেন্ট জিনিস বললেন, যেটা হলো আমরা জানি যে ন্যাশনাল ক্লিন এয়ার প্রোগ্রামের বিষয়ে প্রথমেই যখন আমি কথা বললাম যে PM 2.5 এবং PM 10 এই দুটো পার্টিকুলার ম্যাটার 2.5 এবং PM 10 মানে পার্টিকুলার ম্যাটার 10, এই দুটোর যে বিষয়ে আমরা প্রথমেই আলোচনা করলাম। এনক্যাপ 1 এটা যখন 2017 এ শুরু হয়েছে, এনক্যাপ 1 2026 অবধি এই 1টা চলবে, তারপরে 2.0 আসবে। তো সেই প্রোগ্রামের মধ্যে প্রথমেই টার্গেট রাখা হয়েছে যে কিভাবে এটাকে PM 10 এর কনসেন্ট্রেশনটাকে কমানো যায়, যেটাকে মেইনলি দেখা গেছে 2.5 যেটা ন্যাশনাল এয়ার যে অ্যাম্বিয়েন্ট এয়ার স্ট্যান্ডার্ড যেটা আছে সেটা হলো PM 2.5 এর 24 আওয়ার্সে যেটা কাউন্ট করা হয় এয়ার কোয়ালিটি স্ট্যান্ডার্ড যেটা নেয়, রিডিংটা নেয় গভর্নমেন্ট অফ ইন্ডিয়া, সেন্ট্রালের প্রত্যেক জায়গায় সেন্ট্রাল পলিউশন কন্ট্রোল বোর্ড প্রত্যেক স্টেট থেকে নিজস্ব প্রত্যেকটা সিটিতে বিভিন্ন জায়গায় মনিটর প্লেস করে রেখেছে, যেখানে 2.5 এবং PM 10 এর রিডিংটা নেওয়া হয় এবং 24 ঘন্টায় প্রত্যেক 24 ঘন্টায় এটা নেওয়া হয়। তো 24 ঘন্টায় ন্যাশনাল স্ট্যান্ডার্ড হচ্ছে PM 2.5 এর 60 আর PM 10 এর হচ্ছে 100। এটার যে ইউনিটটা সেটা হলো মাইক্রোগ্রাম পার কিউবিক মিটার, এইটাতে নেওয়া হচ্ছে। এবার সেখানে রোড ডাস্ট একটা বিশাল কন্ট্রিবিউটর, যেটা নিয়ে স্যার এতক্ষণ বললেন। রোড ডাস্টটা কিভাবে আমরা জানি যে কোথাও একটা গাড়ি চলে গেলে বিশাল ধুলো হয়ে গেল, বা কোথাও যদি কাজ হচ্ছে কোনো জায়গায় কনস্ট্রাকশনে, বা ওপেন রোড যেটা বারবার স্যার পেভমেন্টের কথা বলছে, ওপেন রোড থাকলে অনেক ধুলো জেনারেট হচ্ছে। ওই ধুলো জেনারেট হওয়া মানে যত সূক্ষ্ম থেকে সূক্ষ্মতম কণাগুলো আন্ডার 2.5 চলে আসছে, আর যেগুলো একটু বড় সেগুলো 2.5 থেকে 10 এর মধ্যে চলে আসছে। এবার যত বেশি যত পলিউশন বলতে গেলেই ওই যে ডাস্ট গুলো কি করছে, ওই পার্টিকেল গুলো ডাস্ট পার্টিকেল গুলো আটকে রাখছে, যেহেতু হিটটাকে আটকে রাখছে, যে যত ধরনের গ্যাসীয় যেগুলো আমাদের শরীরের জন্য ক্ষতিকারক সেইগুলোকে আটকে রাখছে, সেই জন্যই কিন্তু পলিউশনটা বাড়ছে। তো তার মধ্যে একটা মেজর কন্ট্রিবিউটর হচ্ছে ভেহিকেলস।